Olivia and Carl. Okay. So that would be, so she just got a doctor. She took 87 years. Yeah. Wow. What did she know? What does her doctor do? You might have to look at because they do a lot of events during our health series. I might have to do my patch, my guidance. She's up in New York. I guess they're usually getting a freshman. Yeah. Yeah, tell her I said hello. Very cool. Where are you from? Oh, okay.
Yeah, because that was the first time I thought when I was sitting there next to her.
Oh, where are my friends are back here?
So we have 8 years.
Oh, you are?
But we're not getting back to the
yeah, I'm trying to give them credit.
They've,
yes.
Ian Carr wanted to say hello to you.
And Carr.
Yeah, it's from West Shore.
And
Ian.
oh, Ian Carr. Oh, okay. Well, he's my buddy.
Yeah.
Well, we're doing the Desmos thing during the summer. That's
Are you coming up with the
yeah, I'll be one of the facilitators. There'll be 2 people who work for Desmos, me and at least 3 other fellows. I ran that last year. It was great.
Right. Yeah. We had 2 teachers from
Yeah.
It was more intro, wasn't it?
Yeah, we're struggling with that for this next year. Like, how do we differentiate? Because the audience is so. And usually I walk in the room, I said, who knows Desmos?
Right. Which is good.
But it's good. But people on the station, right?
That's what because I thought we took most of the staff.
Yes. Yeah, this will not last as much very exciting. This will not be us. This is the end.
Is this kind of like an overview? I just was on the outside of the other day and I saw this. It said something like that. But that was over.
Just for the beginning or the whole thing? In the beginning. Can I roam during it? So you prefer here at the beginning? Oh, just turn red.
Okay.
Okay. Oh, I'm sorry. Yes, folks, we're just about to get started. The young lady's going to close the door, and I suppose we're going to get ready.
Hi, good morning. Thank you for coming to the session, having meaningful math conversation with Desmos. So before we begin, please turn off your cell phone ringers, and then the fire regulation requires that all sessions attendees have a chair. There is no standing in aisles or sitting on the floor. Please do not use chairs for your belongings if others are looking for a place to sit. If you are plugging devices into wall outlets, please keep in mind that people may be moving around during the session. Your device may be damaged if someone runs into the port. An Act 48 will still be available at PETEC as we have offered in the past. However, no codes will be distributed this year. You will be able to submit your Act 48 credit online via the evaluation process. You can find the link in the Attendees Service Center on the PETEC webpage. And now I present you to Bob Loach. Loach, I'm so sorry.
All right, thank you, Nicole. I appreciate that. So welcome. Is this thing supposed to be red or blue? It's red. So that means it's on, right?
Yeah.
So we're good. Awesome. All right. I'm allowed to walk around, or am I preferred to not walk around? This is new to me.
Yeah, so the camera is in this area, so
Okay.
you probably can't work too.
Well, I don't want to
close
see
the
me. I
audience.
prefer to go anonymously through life, so I prefer to go up
Okay.
here. That's okay. So yeah, I like to be in the middle. I'll kind of do this. I'm going to be cognizant of this. This is really weird, right? So anyway, my name is Bob Loschel. I'm a high school mathematics teacher. I've been teaching for 22 years. I was also an academic coach in my district for 2 years. And I guess I came to know Desmos back in 2012, 2013 when it first started. This, I think, is maybe a different session than I've done in the past. Usually when I do sessions, it's pretty much all math teachers, but I'm going to guess that I have kind of different people in this room. So I'm just going to do a show of hands for the beginning. Who in the room here is a math teacher? How many math teachers? Oh, wait a minute. So we do have all math teachers. Okay, well, let's just go cut right to the chase then. Who's miscellaneous? So what is miscellaneous? Principals and
Instructional coach.
coaches? Principals? Awesome. So we hope we have something for the coaches and the principals to take back as well. My information is here. I'll put the slide at the end as well with all my information. Please tweet, especially please tweet to Desmos if I missed something or you have a question. Feel free to tweet to them. They answer your questions. They are very good with getting back to you. And apparently that is the hashtag that we are using for this conference as well. Okay? So a little bit more about my experiences. So I do teach at a high school of 1,600 students. I teach primarily AP statistics. That's about 2/3 of my schedule. And then basically it becomes whatever else fits Bob's schedule. So this year I taught Algebra 1 for the first time in many years. Sometimes it's Algebra 2. It's whatever fits in the jigsaw puzzle, right? So whatever's left over. Really what this session is going to be, it's going to be kind of a best of. I tend to do full day trainings. My goal is to try to show you 4 neat activities that I have done with Desmos over time, but I'm going to try to do each of them fairly quickly. My district, we are 1-to-1. We have Lenovo yogas as our devices, but a lot of what we're going to do works for Chromebooks or even if you have phones. So we're going to show you all kinds of solutions today, from using 1-to-1, or maybe if you just have a cart, or maybe if you're the only person in the room who has technology. I'm going to show you a teacher move as well for low-tech solutions and how to deal with that. Okay? So right away, I'm going to ask you to participate in this. This is not a Desmos Activity Builder session. However, if you're not familiar with Desmos Activity Builder, it is a way to facilitate activities with students digitally. It's kind of a neat interface. This is exactly what I would do with my students. I'm going to ask you to go to student.desmos.com. You'll see a place to put in the code. The space is optional. The only reason we put the space there is to help younger children kind of space it out a little bit and see it a little bit better. This is, I will say already, this is not an ideal room for this setting because I know people trying to sit with their computers in their laps and whatnot. So let me give you a few minutes to try to do that. It will also, the other thing it'll ask you is, do you want to sign in? You can continue without signing in, which I believe is at the bottom of the screen. I just want to get some information from the group about where we are. Put the phone down so I can see. Basically, it's going to be 2 screens when you get there. If you've never used Activity Builder before, the way you navigate, on the very top there's an arrow, and you should be able to navigate 2 screens right now. You know your phone is showing up there. getting some fantastic responses out here. You guys already have me chuckling at some of them already, and I appreciate it. Another minute or two. I like some of these. So again, this is not an activity builder session per se, but every now and then I'll give you a peek behind the curtain at some of my moves. One thing you can do with activity builder is that you can select and sequence responses. So I took some of your sequences here, responses here about how can technology energize learning, and I put them up here. Technology helps add why to doing math problems. At its best, it does. We hope it does. Somebody here is a Desmos user. They love the Desmos lessons, polygraph card sorts, Desmos art things, and the response when hitting pause. I'll just add to that one. Is anyone planning to go to ISTE this year in Philadelphia? Come see me. We're doing a poster session with some kids about Desmos art. So that's going to be a lot of fun. Engaging students with higher order questioning, that's a big deal. That's a lot of what this session is about. So we have all this technology, it's great to have a tool, but that doesn't change my role. In fact, it changes my role in that I need to think differently about how I'm going to get responses out of students. How are students going to discover things through technology? I love this. Someone had an aha moment here. Oh my God, it's a limit. Fantastic. Yeah, I like that. Oh, now I'm going to go back to this one. Someone who has used Activity Builder before. The response when hitting pause. I don't know who wrote that, but what's that response when you hit pause? Oh. Yeah, boo. Right. So if you ever want to have a mathematical sugar rush in your classroom, do an activity, and at some point where it's strategic and feels right, give them a pause, and you will have kids booing you because you stopped them from doing math. And isn't that awesome? Yeah. I prefer to keep doing the math, but yeah, if you've never used pause in Activity Builder, it's really a cool little thing to do. Let's look at some of the ways that can hinder learning as well. Let's look at some of these. No real surprises here. Digital worksheets, yes. I actually tweeted out a couple days ago. I was watching kids do work during their lunch period or their study hall, and we use OneNote a lot. And someone had clearly just taken it was clearly typed at one point in time, a typed worksheet, and just uploaded it to OneNote. And a little bit of me died inside when I saw that. Can we change things a little bit? Too much technology? Yeah, we can overwhelm with technology. Tech issues, yeah, Wi-Fi goes down every now and then, and it's too easy to be at a different site or off task. So in this session, I'm going to give you 4 exemplars of what I hope are ways that you can facilitate conversation using Desmos. Okay? So remember, there's 4. So here comes number 1. So that means I got about 15 minutes for each. Part of it is I can talk fast. I can also be very enthusiastic about things. If something goes way past you, that's okay. At the end, I will show you where you can get resources, where you can get documentation. I am going to show you some moves with Desmos. If you would like to do it with me in your computer as you're doing it, great. If you feel like I'd rather just watch and I'll try it on my own later, that's great too. I'll show you where you can get all this stuff, okay? If I do a move and you kind of need the 30-second, hey, how did you do that? Can you rewind? I can do that as well. Okay, so here's the first one we're going to do. So just like any class, I like to have something in my on my screen as kids walk in, and so here is my little visual one act for you guys here. We have a picture of a cell phone here, and what I'd like you to do is with the people around you, let's take about 30 to 60 seconds. What do you notice about it? What do you wonder about it? Take some time. Share with the people around you. What do you notice about it? I'll get it out of the way. Before you yell at us.
Desperately in need of yeah, just looks like that screenshot was taken before lunch.
Hello. Okay. So again, 4 activities in an hour. This is when I usually do trainings. This is an activity that ends up taking 45 minutes or so to go through the whole thing. You are getting the express version today, so there are going to be some moves that I kind of go through that I shorten a little bit. One will be here, like if I have kids tell me what did they notice and wonder, I'm usually going to document, maybe we'll put it on a poster board or something like that. For the ease of time, just kind of get my attention. Name something you notice or wonder about the phone.
Charging.
It is, how do you know it's charging? It is charging.
Lightning.
A little lightning bolt means it's charging. Awesome. Other things. Yes, sir.
Is it AM or PM?
Is it AM or PM?
Yeah.
PM because Starry Night usually means PM. Any others? Other things you notice and or wonder?
The alarm is set.
Alarm is set. How do we know that? Oh, because the little alarm clock. Yeah. Alarm is set. Any other small things? What do you have, sir?
So do not disturb, so I can pump charge.
Yeah, what is do not disturb again? How do I know this? Is that the little... Yeah, the little do not disturb. Okay. Other things we notice?
The Bluetooth is on.
I'm sorry, say it again.
The Bluetooth is on.
Bluetooth is on. We got a lot of things going on. Is the Bluetooth on?
Yes,
symbol's
it's not.
The symbol's there. I don't...
It's not connected.
Help me out.
Do not disturb disconnects it.
Okay, there we go. We got a lot of things going on here. Okay. Yes, sir.
It's summer.
It is summertime. In fact, I will tell you the response that I've gotten. I never get it from adults, but I got it from a kid. It's free Slurpee Day. I never get that from adults. Kid goes, yeah, it's free. And the first time a kid said that, I was like, what the hell are you doing? Oh, it is free Slurpee Day. That's awesome. Did he get his free Slurpee? I thought that's a wonderful response. Okay. All right, let's get down to the mathematical nitty gritty though. What do you wonder about this phone? What do you wonder? What do you wonder, sir?
What did that person do to drain your battery that far?
Yeah, what did they do? So they're really living life on the edge, right? They're 5%, it's Friday night, uh-oh, we gonna make it?
Snooze. Are they going to push snooze?
Are they gonna push snooze? Okay.
How long will it take to charge?
How long will it take to charge? So this is the one we often have a debate about, because there's 2 questions here. How long will it take to charge, or how long will it take before it's totally dead? And which way are we going here? Are we going up or down?
Well, you're plugged in.
We're plugged in, right? So there's evidence that we're plugged in. So we're charging. So the question we're going to go with is, how long will it take to charge? Okay, when will the phone be fully charged? And I'm going to ask you to do something in your groups. I was going to do this in a tech way, but again, I'm trying to get the 4 activities. With the people around you, I want you to use a technique that's really wonderful. It's called Goldilocks estimates. I could very easily just ask the room, what's your estimate of when it will be charged? And I would get a lot of different answers. But with kids, there's a wonderful technique you can use. Give me an estimate that you know is too high. Give me one that you know is too low. So you got to think about reasonable boundaries and try to be brave about them. And then give me your just right. So it causes kids to really think about what are those boundaries going to be. So it's a nice technique for estimation. Again, if I was doing an hour, much more than an hour session, we would go through the activity of doing all that. We're going to kind of skip that one. So just mentally, how long do you think it might take to charge? How many minutes do you think it might take to charge? How long do you think it might take to charge? Yeah, and I'm going to kind of center you to the idea of how many minutes. In a discussion, we might flesh that out. Who's bold and brave and can give me an estimate? How long do you think it might take?
48.
48 minutes?
Yep.
48 minutes. Anyone else? Don't Price is Right her. That's not nice. 49
I was
minutes.
thinking 45.
45 minutes? Anyone else? Okay. Whatever you have mentally, just kind of tuck that one away. But this is a Desmos session. I'm 16 minutes in. We haven't done any Desmos yet. So here we have to do some Desmos, right? Now, what would be helpful here to help us get to the idea of how long it might take to charge is if I gave you more screen grabs. Now I'm going to cheat and give you more. So already we're 24 minutes in and we're up to 33%. And again, in a workshop, I would give people time to kind of pencil and paper this out and think about it. 4 activities in an hour. We're going to skip that part. But I'll ask my people now who said 48, 40. Oh, I'll move out of the way. I will share these slides with you at the end if you like. Okay. What are you going to say now?
1 hour 25.
So she's revised upwards. So at 85 minutes now. Anyone else want to revise their guess? That's okay. So we'll go with, what is it, 85? 85 minutes is our current tribal guess. Okay. So let's go to Desmos and see in Desmos world how we do this. So let's kind of, first of all, let's get a tone of the room here. Who here has never ever used Desmos before? Okay, and that population's dwindling. So we were talking about this earlier. It used to be when I would say, who's never used Desmos, I'd get most of the hands have shot up. So some have never used it. Who would put themselves in, I've kind of sort of used it, but not that much group, okay? And who would say that I'm bordering on, yeah, I use it a lot? Okay, look at that. We're like 1/3, 1/3, 1/3, right? So everyone, so it's going to be a tough group, but we'll try to meet to the middle here. So I'm going to invite you to go to desmos.com. And again, this is where I'm going to do and show you how to do the problem. You can try to stay with me, or you can just kind of watch and then think later about, oh, okay, I like those moves. I'll try to learn them on my own. The best thing for kids to do is to just click the Start Graphing button, and usually when I do that, it just takes me right to the calculator. But I do want to point out some other features here. 4-function calculator, scientific calculator, teacher.desmos.com is where you get activities. It's nice to just take an exploration there. And I will point out if I go too fast, learn.desmos.com, take skills down to the granular level, and you can learn them on your own. So if you lose something or if you forget how to do something, you can always go there. I will point out a couple other things. Anyone here use the app? Some people have the Desmos app. It's awesome. Something brand new I started using for my classrooms. If you have an iPhone, there is a Desmos test mode app. My students may now use it on tests. Instead of being green, the Desmos green, it has a blue border, and it asks them to start the test, and it locks them out from every other app. And when they're done, they stop the test, and you can show the teacher, I've been working for 90 minutes. It has a clock on it. So you know they've been on nothing but that app for that amount of time. Yes, sir?
Do you know if do they have internet access to access that app, or is it?
Once you have it loaded, you do not need it once you have it loaded. I mean, to load it, you have to have it on there. But no, you do not need to have internet.
Once you have the app, they don't have to have cell connection.
Yeah, that's like once you have it on your phone, you don't need it. You don't need access as well. Only if you want to save things, but for the app, for test mode, you wouldn't want to save things anyway. Yeah, that's good. So
Is it test mode on a Chromebook, or is it only like a Google Play app?
They have an extension for Google.
Yeah, they have one for Chrome. And if you have an Android for your phone, they had one, and it's easier to lock things out on an iPhone than it is on an Android. So it works well on an iPhone. Android, the test mode app is not quite there yet. Okay. All right, so let's do some math together. So I'm going to go up to the very top again. We're going to start graphing here. I'm going to point out one of the neat little features under the wrench here. We're going to use projector mode so it becomes nice and dark. And I'm going to enter in this data. To enter in data, I'm going to go up to the plus sign here. And I'm going to add a table. Okay. In this scenario, what is my x and y going to be? What's my x going to be? Let's do one at a time. What is my x-axis going to be? Time, let's make an agreement here. Can we say it's time since it started at 9:02, right? Can we say time since 9:02? So at 0 is at 5%, right? Time 0. And that's where I have to go back and cheat now, remind myself. So basically my x's are 8 minutes, 12 minutes, and 24 minutes. 8, 12, and 24. Double check me if I'm wrong on that. I think I'm okay. And my percentages are 5, 14, 19, 33. 5, 14, 19, 33. It's good. Okay, so it's on my data. I can also label the x and y axes under the wrench. This is where you put like your zoom settings, and if you want to change the x and y axis settings, what their max and what their min are. I'm going to show you another way to do that as well. But I can label them. My x-axis is time since 9:02, and my y-axis is percent charge. How much is charged? And again, right now I can't quite see it, but I can drag here and I can move it around. We're only talking about the first quadrant here. And if I zoom out, zoom out, zoom out, that looks pretty nice. Okay. I will point out one other thing you can do. Sometimes zooming out in a square way is not what you want. You want to zoom the x and the y independently. So Desmos added a feature for this, I think back in May. If I wanted to, if you hold down the shift key, watch what happens when I hover over the y-axis. See what's turning blue there? I can now drag this one independently if I want to. In fact, I want to. Ooh, I heard that. I heard the gasps of, ooh, you are such nerds in this room. That you go to 100%, I can just have it go right there. Because I do need 100%, right? That's kind of our goal. So I can put in the line y equals 100. Okay. Now, at this point with students, I might say, okay, we have the data in there with the people around you. Take a moment and type in equations that you think might be a reasonable representation for the data. And we'll start just by typing it. I'm not going to show them. I know some of my power users might think, well, you can do it this way too. But at the beginning, I just want them to kind of think about the numbers. So maybe I'm just going to start by typing in y equals 2x plus 3. And I think, ooh, that's not great. So we're going to toy around with that a little bit. 2x plus 3, oh, the slope seems like it needs to come down. Maybe it's just x plus 3. No, not quite there. If I think a little bit, what should my y-intercept be? Should be 5, right? Because it started at 5. Let me figure that out. And now we're going to toy around with that. What's best? Maybe it's 1.2. And I'm going to ask students to have these comments. Well, actually, 1.2 is pretty good. I do say so myself. That's not too bad. I'm kind of proud of that. Okay. Well, it's pretty good. Okay. We can toy around with that. Okay. Another way to do it. So I'm going to turn this line off, by the way. And the way I'm going to turn it off is by clicking the red next to it. That gets rid of it. So I can toggle it on and off. So it's not gone, but you toggle it. But another neat thing you can do, instead of y equals, and put the numbers in, if you tell it y equals mx plus b, you get this wonderful command, add sliders. Would you like to add sliders? Why, of course I'd like to add sliders. That would be awesome. So I'm going to add my sliders. And now I have this wonderful interactive. It is like the most basic, easiest thing you can do with Desmos is to make yourself a little interactive display with students. Okay? And that'll work even if you do, let's say you do a quadratic. If you tell your quadratic, I want y equals, what's the format? A parentheses x minus h squared plus k. It will ask you, would you like to have sliders for a, h, and k? Well, yes, please, thank you very much. I would like to have sliders for a, h, and k. And that'd be awesome. So you can make these little interactives. As long as you put in a parameter instead of a variable, it will ask you to make a slider for it. And now I can toy around a little bit more and kind of get closer and closer to it. My b is 5. And in fact, if I'm committed that the b is 5, I can just make this 5 and just have a slider for the m, right? I can toy around with it. And again, in a workshop, I'd give people a lot more time with this. You get the short version. 1.2 is not so bad, it looks like. Does anyone have one they like more? If I wanted to, if I want more granularity, if I want to change my endpoints of a slider here, you just click either end. I know it's got to be between 1 and 2, so maybe I'll set the slider to go between 1 and 2 and count by 0.01s. I really want to get to that granular level, get some finer tuning. 1.18, that seems kind of nice. I'm getting there. Okay. Other small things I can do here, I can even chop this thing off. I know I don't want to go beyond here, so I can even say, oh, just do this when x is less than, oh, x is greater than 0. We can restrict domain and range as well. We got that. And according to this, if I come up to here, I can see, hey, wait a minute, according to this, if that's the line of best fit, if that's what we like, it looks like it's going to take 80.5 minutes. And yeah, I like how you pointed that out. You're like, oh, you're pretty good. Yeah, she's not bad, right? 80.5, and you said what, 125, an hour 25, right? Is that what we went with, 85 minutes? Oh, she's so close. But is she right? Now for the stat people in the room, this also means I would like perhaps to do a regression on this. I want to find the line of best fit. So let's explore how do we do a line of best fit as well. So we're just going to get rid of this guy. Now, a line of best fit, there's two things you've got to remember. We are no longer taking x versus y, we have actual data, x1 versus y1. And the other thing we're doing is it's no longer an equals equation. This is an approximating equation. So I'm going to type in y equals mx plus b, but with two changes. I'm going to use x1 and y1, and I'm going to use the little approximate symbol. If you look in your keypad, it is that button you never use to the left of the number 1 as a shift above the exclamation point. Is that where it is? Or, and I will be honest, I don't use this all that much. On the bottom here, I do have an array of things that I can use, and it lives in here somewhere. Yeah, there he is. I do not use this all that much, but it is there. You have a keypad down here as well. Whenever I do these trainings, there's something I always do forget to do. I have to be careful with y equals mx plus b because I've already used m. So I can't use m again. But I am going to do y1. It's approximately equal to. I'm going to use k this time because I've already used k. I've already used m. So k x1. And I'll point out, when I say x1, putting the 1 there, it subscripts it. It automatically knows, hey, he probably wants a subscript. kx1, oh, and I can't use b because I've used b already. So it really doesn't matter what parameters I use. But I can use plus c. Let's be careful about repeating. And according to this, oh, our k is 1.17. Our c is 4.88. Again, I could have made that just a 5 because I really do want to commit to that 5. And that's fine too, I can do that. Apparently 1.16 seems pretty nifty. Okay. And according to this, we will have 81.667. 81 and 2/3. We seem pretty good. 85 doesn't sound so bad. Okay. But is it right? Of course you want to see the right answer, right? You can't have a math class and not see the right answer. So I will show you, and I can share this with you afterwards. So this is an activity from Michael Fenton. He actually did one night take his phone and he took a picture of it every minute or 5 minutes or something like this. So what I'm going to show you here, this one's already set to go. He has his Act 2 data, which is the data we put in. He put in his line of best fit, which is the same one we had. I think it's still going to intersect that same point. 81.43, kind of close-ish. And now what's going to happen here when I press this play button, it's going to show you every 5 minutes what happened with its phone. So let's see how good we were with our estimates here. This is the actual data from his phone. 81.7. Looks so awesome. We are fantastic. We are going to be right on there. We are going to exactly have it. And, oh, shoot.
He
Wow.
didn't tell me when he bought his phone. That's like a bad battery.
Yeah, this is kind of cheating, right? This is the part where students will blame you because you lied to them with math, right? How dare you have us do a regression and you lied to us with math? I will share the actual answer is 11:22. So if I go backwards, how long is that? That's 2 hours and 20 minutes, so 140 minutes. Yes, I lied to you with math. I'm really sorry that I did that. I've heard various reasons. The most compelling one I heard is that as your battery charges, it slows down so as to protect your battery, and people are head bobbing. So you're buying into that. Awesome, because I really have no idea. So your phone doesn't explode. Okay. All right. So I had an ambition to do 4 lessons today. That's number one. It is the one that takes the longest. Okay. Any comments, questions about any small moves in there? So just giving something perplexing to collect some data and think about it is the first move? Yes, sir.
Just to add a couple of things.
Yep, go ahead.
I've done this before. Like,
Yep.
When kids come up with their line of best fit and throwing it up there and then seeing their, like, just having those conversations, comparing their own models, is just another teaching move that you do with this class.
Yep, fantastic. I'm going to talk about this. If you're in the eastern side of the state, you teach at Westchester East, West?
I'm at the middle school.
At the middle
Westchester
school.
and
Westchester is going to be hosting a Desmos 2-day training June. It's a Wednesday, Thursday, the end of June. Be on the lookout for that. If you go to desmos.com, somewhere on there, they're posting the summer institutes. It's going to be restricted to 60 people. We ran one last year, so if you want something more immersive, that's where you get this big picture stuff. So they'll be in June, and they're gonna be the hosts. So it should be pretty cool. Okay. Next what we're going to do. So the next activity I'm going to do is one that has changed the way that I teach sequences and series. Okay. And it does come down to a website. If you've never been to Visual Patterns before, wonderful website. Who here has been to Visual Patterns before? Oh, great, 2 people. All the rest of you, make sure you have this one down. This is a site curated by Fawn Wynn out in California. If you don't know Fawn, you should know Fawn. Fawn is awesome. She's primarily middle school. She has a lot of great Algebra 1 stuff. And all her site is a bunch of pictures like this, where students are asked to think about the pattern. These are 3 representative ones. I actually made an attempt here to give you one that's easy, medium, and one that's a little bit trickier. So we have all types here.
You know, Bob, she has an updated version of the Math Talk site that has the visual patterns and the number talks too.
Do you know the name of it?
It's just mathtalks.net.
Mathtalks.net. There you go. Awesome.
It's still fun, though.
Yeah.
It's just her newest version.
It's amazing. Some of these sites that are now, this one's been around for a while, now they're starting to update and change what they do. So let's talk about the first one. What are some things we could ask students to do with the first one? What are some questions we could ask about? Let's take this. 60 seconds. Talk to the people around you. What are some prompts that what could we ask students to do with these? Go ahead and think about it. What could we do?
I know. We used to come in and try to do
Because they break the shape of the part. School, and you're the closest part you go. I go, so this part,
What would we like to ask students? What are we going to ask the youths to do with it? Yes, sir.
Given that you have a square area total, what's the ratio of orange to white?
Whoa, he just went way up there. I got you. So sometimes I get the same responses over and over. He just went someplace where it's like, given you have a square area, it's like, I don't know where he's going with this. But now, again, that's pretty awesome. You mean, given that there's a square, imaginary square around it, right. What is the ratio of orange to, wow, you are just next level here, buddy. But that's fantastic, isn't it? It's a great one. And now I want to explore that one. How awesome. What other ones do we have? They don't all have to be like that.
Draw the next one.
Draw the next one. Yeah, if this is just a 6th grade or 7th grade classroom, just draw the next one. Draw the next 3. What do they look like? Okay.
Predict how many will be in the 150.
Yeah, and that's what Visual Patterns does. It asks you how many are in like the 43rd and the 51st. And I think she asks goofy numbers like that because you don't want kids just multiplying it by 3 and saying, here's what you get. So she asks prime numbers, I think 43 and 151 or something like that. 2 goofy numbers. Okay. Or if you're like in an algebra class, what's an algebraic pattern that provides a rule for the pattern. I will tell you, if you ever do the middle one, if you just have a math department chat, doing the middle one and saying what is the algebraic pattern for it is awesome, because you will get 8 different ways of doing it. People perceive it like 8 different ways, but they're all equivalent. So when you do it with a class, you say, wait a minute, here's all these different responses we got, let's show that they're all equivalent to each other. That middle one is really awesome. I'm going to focus on the top one. So here's what I do with the top one now, using Desmos. Here's how we talked about it in my class. So we're going to go back to Desmos again. I want to start a new graph, so I'm going to come up here to the hamburger, the 3 lines. I'm just going to do a new blank graph. That's good. And we're going to start off by making a table. We have data. It is in a table. And I have the first 3 pictures in the sequence. And help me out. It's 5, 9, 13, if I believe, right? Yeah, 5, 9, 13. And the purpose of this is it's really hard to just tell kids, come up with the algebraic formula. That's really tough to do, even for simple ones sometimes. How do we dissect what's going on here so we can come up with that rule? And this has really changed the way I do things. I'm not so worried about the graph in this one, although if I look here, it does look like something's going on. I'll zoom out just a little bit. This is one of those times, the x-axis, maybe I don't need it going up to 20, so maybe I just want to spread out a little bit. Okay? It'll just help confirm what I do. This is going to be very table-based. Okay? So I have 1, 2, 3, 4th. How many do we predict are in the 4th? 17, right? And the 5th, we predict there are 21. And now all heck breaks loose when I say, okay, smarty pants, how many are in the 53rd? And like, okay. Now some will get it because they'll kind of figure out and they'll do their little 4s and things like that. But the goal is to come up with a formula that lets us predict that 53rd, right? So I'm going to go back again to the picture. And I've still struggled with the wordsmithing on how to do this one. How are these constructed? How are the pictures constructed? What's negotiable? What's non-negotiable? What is it they all have? What's changing? I'm trying to stay away from variable. I'm trying not to say variable. I'm trying really hard not to say that. But how are they constructed? How do you perceive that they're constructed? And there's 2 different answers that I get from kids. Some kids will say, oh, it starts at 5 and 4 get added to the outside each time. Perfect. Or the alternate is, oh, there's always 1 in the middle and then 4 more and the 4 more grow. So you can do it either way. It works either way. I'm going to go with the 1 and then 4 more get added. So where I'm going to go back to this is, I'm going to now start a new column. I'm going to call it Y2. And the way I see that 5, it's not really 5. It's 1 in the center, and it's always there, plus 4 more. Right? That 9 really isn't 9. It's 1 in the middle, plus 8 more. And then 1 plus, well, then 1 plus 16. And then 1 plus 20. Okay? Awesome? Is that helpful? Starting to see things a little bit. Again, speeding along to get the 4 activities. So we're going to the Y3 column. Now, I am going to another column. I'm actually going to use, I think, no, this will be the last column. But it's already starting to take a little space. I can just drag the table. This is very table-based, so I can just drag this part here. I need more table space. Oh, now that I've done it like this, I see 4, 8, 12, 16, 20. So really, that one is really, oh, it's really just 1 plus 4 times 1. And then 1 plus 4 times 2. So we're breaking it down to its components, right? And then 1 plus 4 times 3. 1 plus 4 times 4. 1 plus 4 times 5. Okay, smarty pants, how do I get 53 now? Yeah, we've broken it down to something that's very comfortable, and now I see the repeated regularity in what's going on here. 1 plus 4 times 53, and now I can work backwards. 4 times 53 is 212, right? So 1 plus, yell out if I'm wrong there. 1 plus 212, so therefore there's going to be 213. Fantastic. When I do sequences in series with my students, this is now how I start off with it, and I get the patterns, the arithmetic and eventually geometric sequence formulas. And even better now, I can go up here. I now see the pattern here that the way these are broken down, it's always 1 plus 4 times something. What's the something? X1, and it is the X1, right? 1 is 1, 2 is 2. If they do it differently, if they do it as 5 plus, and they go with that, then they'll have to use X minus 1, which is fine too, because when we can talk about what the differences with those are. So in this column now, I can now tell it, let's do 1 plus 4 times X1. And it's going to populate the whole thing. There's my columns. And that's kind of changed the way I do arithmetic sequences and series. It's kind of neat. It breaks it down to its core components. Okay. Again, trying to get the 4 things today, but maybe we can take like 30 seconds for this one. If you had to do the blue one, how do you perceive the blue one? And just because it's fun, let's take like the people around you. How do you perceive that blue one? Go ahead and discuss for a minute or so. What do you say?
There's a piece on the lower left, and then there's another piece on the
I see it one definite way that I was tied to, but I love the different ways. It's a good one to do with kids. This one's really cool.
This one's really interesting.
It's really a neat one. Anyone want to share how they see it? Again, what do you see, Mark?
Well, I just saw it now. I was talking to Nicole. What I just perceived in step 3, which also holds the other, is there's a lower left portion, which is, and then the other part is just a reflection of it.
Okay, so we have, what shape?
With that,
What shape do you see them as?
I see like a rectangle with a little
Rectangle with a
appendage.
dot?
Yeah.
Okay, right?
Yeah.
Yeah, like a little hinge going on?
Yeah.
Just to share, the way what do you see? Yeah.
I see the 3 constant,
Yeah.
and then the rectangles growing one width, one length.
Yeah, and it's almost easier to start at the end one. It's hard to see the beginning one, but the way I see it, and it's not the right way, is I have this one, the hinge, this one. They're non-negotiable in every picture, right? So I always have this one, the hinge, this one. It is here as well, it's just tougher to see. This one, the hinge, this one. The 3 are always there. And then there's 2 rectangles. And then getting to the point of, okay, now we're going to break down those 2 rectangles. So I have 3 plus 2 3x4 rectangles. So eventually that's how my column in the table will look. And eventually it's going to lead to a formula. It leads to a nice quadratic on this one too. So that one's a really neat one to break down.
But what's cool with that one is if you give kids like the actual shape and some like markers and stuff,
Yeah.
they break it.
Oh, yeah.
That makes them really see it. Like
Yeah.
they would break the 2 things in the hinge,
Yeah.
and then the rectangles really pop up.
Yeah, they like draw a rectangle
Yeah,
here
yeah.
and here, and I'll draw. So if you ask them to draw the 20th one, maybe they'll just draw the rectangle and know. Yes.
I have kids who like break off that first column and that top row and
Yeah.
make it squares.
Yes. Isn't that cool? I see where you're going. You got this 1x4, and there's a square here, this thing, square, and there's still the hinge. I've seen people do it as exclusion as well. It's this whole thing, and then there's kind of pieces taken out. The pieces taken out are not fun, but there's pieces taken out. Okay? So yeah, that's a neat one to do with kids, but it comes out as a quadratic. Okay? All right, 4 activities in an hour. How much time we got left? 20 minutes. We can do this. This is awesome. All right, here's where we're going to go next. This one, the next one I'm going to show you is called the what if machine. This is a wonderful solution if you are not one-to-one, if you just have a computer in the front of the room, or if you just want to have kids close their laptops and just kind of watch and have a discussion. That's what this is perfect for. Okay. This one came to me. Christopher Robinson showed me this one. I'm going to start over again. I'm going to go to new blank graph. Okay. I'm going to start with what's called a list in Desmos. A list is just exactly what it sounds like, a list. So I'm going to go capital A equals. The way you make a list in Desmos is you just make a square brace. And I'm going to tell it to do 1, 2, 3, whoops, 1, 2, 3, 4, dot, 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 up to 10. What did I do wrong? Oh, I got to put a comma. What am I doing wrong? Oh, wait a minute, I don't like that. Too many dots? There we go. Dot, 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 10. How many dots did I put? I put too many things, whatever. So I have a 10-element list, okay? Now, I'm going to type something in the next one, but I'm going to intentionally screw it up by putting an apostrophe at the beginning. That means I'm going to show you something, but it's not going to calculate it. It's going to think it's gibberish. What I want you to think about with the people around you is, how do you think Desmos will respond to this command? So if I tell Desmos to plot ordered pairs that are A, comma, A, what do you think is going to happen? Take a minute, talk to the people around you. What do you think is going to happen if I do A, comma, A? What do you predict? What's your conjecture? What do you think is going to happen? I'm on 12:30 on that. We'll find out it's 12:15, but I messed up the whole time. Thought's idea is, what do you think is going to happen? Who's willing to go out on a limb? What do you think is going to happen? What do you think is going to happen? Thank you.
So I've never done this before.
Yep.
What I think is going to be like an array where it's the point 1, 2, 1, 3, 1, 4, 1, 5, and then the point 2, 1, 2, 3.
So how many dots do you think it's going to be total? I think I want it.
100.
Oh, you think 100 dots? Okay. So it could do one. It's going to do every possible combination of 1 to 10 and plot them all. Okay. Anyone think anything different? Is that what you want? Kind of have your hand up. What do you think was going to happen?
Well, it's A and A, and A would have the same value as A, so it wouldn't be the same number.
So what do you think it's going to
So
find?
you put 1, it'd be 1 and 1, and then 2 and 2.
1, 1, 2, 2. Okay. And those are usually the common answers. It's going to do one of those two things. Okay. So let's get rid of the apostrophe now, and let's see who's right. Who is right? And we kind of know it's going to be first quadrant, right? So we'll move the first quadrant. Yeah. Yeah. So it does do, and both of them I think are totally reasonable responses, but it does do a one-to-one relationship because it considers those as positions. I'll just show you real quick. I might screw this up. It does consider them as positions. If I tell it what is A, capital A, 2, the second element in A is 2. So it does match up first element with first element, second element with second element. So if I had another list called B, it would take the first with the first, the second with the second, the third with the third, and keep doing that. Okay? So there's AA. All right, let's keep on moving up with it. What if I did, let's get rid of this. I'm going to screw it up again. Move around a little bit. What do you think is going to happen if I do A squared? What will happen? And again, think like kids. What do you think is going to happen? It's a nice little 5-minute opener just to get them thinking. What do you think is going to happen? Okay. I see a lot of people doing this, right? So we're thinking, yeah, I'll take that as a universal sign if we think it's going to make a parabola, or at least it's going to make the points in a parabola, and you'd be right. And we'll use the shift move down to show that does do that. Yep. At least those integer points in a parabola. Okay, what else can we do with this? What do you think it's going to do? I'm going to amp it up a little bit. What if I do the points? Sine A, cosine A. And this is where, I'm sorry if you're my middle school folk. I think it's going to do. I'll give people a minute to think about it before we do it, but thank you. What do you think it's going to do, sir?
Only show 2 points.
Only show 2 points? Which 2 points?
Because the sine, cosine, and maximum values of 1.
Yeah, probably have to move this around here.
Maybe only show a point.
Yeah, I actually didn't rehearse this one, so I wasn't quite sure what it was going to do. Let's see what it's doing here. Yeah. Well, it's doing it in radians, so it is plotting. Yeah, it's plotting. Yeah, some weird values. I guess I have to think more about that one. I've never done sine A, cosine A before. I got to think more about that one.
Well, the graph
To experiment.
The graph goes pi to pi, right? If you did it in.
Yeah, so this sine 1, cosine 1, I got to wrap my head around those values, and honestly, I don't feel like doing that right now. But that's a neat one to try, right? Also means you got to set them up, rehearse them before you give them to kids. Sometimes I don't mind. I don't know what this is going to do. Let's find out. Okay, let's do a different one. What about this one? So I'm going to put my apostrophe back. How about I do y equals ax plus 1. What will happen? What do you think is going to back going up? What will that do? Think about asking Algebra 1 kids. This is just like your 3-minute opener. You throw it up there. What do you think is going to happen? Tell me what you think is going to happen. With hands in the sky, what do you think is going to happen?
10 equations.
Yeah, I guess it's tough to say, right? Yeah, it's going to be 10 different equations, all with different slopes from 1 to 10.
Right.
Then all the y-intercept of 1, so it looks like that. Okay? Yeah, hands in the sky was not ideal for that one. Yeah. Spaghetti. You threw spaghetti all over the countertop. That's what it looks like, right? Okay? I have 2 more. What if I do x plus, oops, A? Yeah, maybe it's my opener the next day. What's going to happen with it? Okay. Yeah, there we go. That's what I thought I was doing the first time, and I realized I was doing the other one. Yeah, it's going to do stacked lines. There you go. Ready? Ooh, right. Put them all in there. Okay. Last one of these guys. Yeah, so you don't have to have all the kids on a computer. You can just facilitate the conversation up here, right? Here's the last one. X squared plus y squared 1 equals A. Ah, I heard the aha. I like when I hear the aha. It's like, oh, he's using this one. What's gonna happen with it? Yeah, I know you're circles, right? We're gonna make circles. If you don't teach algebra 2, then yeah, these are the equation of should have 10 circles. Kind of cool. 10 circles. 10 circles. Are they equally spaced apart? No. Why aren't they equally spaced apart? I used 1 through 10. Algebra 2, maybe a nice follow-up question. How are they spaced apart? What's the ratio of the spacing apart? Yeah, they're clearly not spaced equally apart. Why aren't they? I use an arithmetic sequence, right? Yeah.
Almost looks three-dimensional.
It does, doesn't it? It's pretty cool. Yeah. Yeah, that's where you put some hyperbolas with it too, and you get that magic eye stuff that drives my eyes bananas. That's really neat. Yeah. So the what if machine, just coming up with this little list and then just coming up with some things. That's a great like 2 or 3 minute opener with kids, just to get them thinking about what's going on in your class. All right, 13 minutes left. For this one's my favorite. Okay. All right, so this last one is going to need Activity Builder at some point. So remember we started today with an Activity Builder? Whatever device you use that on, you might want to go back to it. In a minute, I'm going to ask you to go back to that Activity Builder. But first, I'm going to show you what this is all about. Okay, Calc and Conversation. I have a video here from a site called Graphing Stories. Graphing Stories was a site that Dan Meyer had curated for a while. I don't think he's added anything new to it for a while. But they are 15-second videos that you show kids. There is a grid paper you can hand out, or you can just do it freehand. It asks kids to come up with a graph of the relationship. And this one is, in the 15 seconds, come up with a graph of the height of his waist off of the ground. This is my buddy Adam, who I think is in, actually I don't know where Adam's from. So I'll talk about where he's from. And hopefully, there we go. Yeah, do a full screen on. It always starts with this. You are given this kind of grid paper. Here comes Adam, who, by the way, had to go to a playground on a Saturday morning to make a video. There he goes. And there he goes. I'm going to stop. Okay. So in the past, I've done this one with students, and I would just hand out the little slip of paper. We now have that in the Desmos environment. So by the way, I'm going back now to the Activity Builder. Notice the first 2 screens, I have paced you to those 2 things. I'm actually going to pause you. I'll undo the pacing, and I just want to go from here, from here to here. Oh, let's go backwards. 4 and 5. So if I unpause you, what should happen in the Activity Builder, it should take you to screen 4, it'll let you watch the video, and then in screen 5, it's going to ask you to sketch the relationship. Okay? If you did not get the Activity Builder before, or you closed it, and you didn't know you were going to need it again, the code is up there. You go to student.desmos.com. Another great teaching tip with this one, it's great to put 2 kids on one device for this and let them argue it out and think about their response. Okay? I'll give you a few minutes to play with that. Weird around about it. Okay. You should be restricted to 2 screens. This is a cool activity going on. If you're on a phone, this might be a little wonky for the phone. It's a lot to go on the phone screen. Yeah. It'll let you do it. It may have to throw it. I will tell you that 4th screen where you're just typing in things you noticed, it's okay to just skip back to the right. The screen 5 isn't anything when you draw. That's the end of that. So feel free to skip over 4. I want you to do 1 or 2 minutes. Which of your kids will attend precision here? Which will just give you a graph. That's one of the great reasons if you want to put 2 kids together. Make the duo responsible for putting together a nice representative graph. and for people who are watching me, so part of the teacher role as kids are working is to kind of surreptitiously look at student work and say, okay, these are the ones I really want to highlight. That gets to be really difficult. It's tough to walk in and chew gum and do all these things at the same time. While kids, I'm leaving the kids to work, I'm just picking out ones that I think are interesting.
Or other things in middle school.
Okay, now I'm very disappointed in this group. I thought we were friends. I heard one whimper of awe. So we're gonna try that again. Usually I give my kids a warning, so I let you work, but all of a sudden I pause. Exactly, or boo. My kids are allowed to boo. You're allowed to flat out boo. Usually I give my kids a warning. I'll say 30 seconds till pause. And then 30 seconds later I'll forget the pause and I'll say it again. That's usually what happens. Okay. So here are 4. Here's exactly what I did with my Algebra 1 class this year, because we were talking about functions. Because you want to make sure kids are drawing things that are functions and no non-functions, that sort of thing. So, and these are, honestly, this is the nice variety that I got from my Algebra 1 class. So we took a pause and said, okay, let's discuss things we notice, we wonder. What are some things that are different? What are some things I'm going to be happy with? And then again, because of time, because we're at 12:23, I'll point out, oh yeah, what did they do differently? What's different between this one and this one? Oh, they put this little ridge here. Well, why did they put that little ridge there? Why did they put that little ridge there? Yeah, he sat down, and he's kind of squatted down, and he stopped, right? So he stayed level there. That means he was at the same height for a little while, as opposed to whoever this was, seen the thing that they just slid, and they went off the face of the earth. And I guess they're gone forever, I guess. So what I allowed kids to do is, after we discussed it, and we didn't talk necessarily about right and wrongness, we talked about what do we see that's different and justify why it's different. I unpaused the activity, and I didn't want to go back. So they were allowed to go back again and rethink about what they did, and by the time we were done, pretty much everyone had agreed on what it is, on what the correct one is. So it's a great way just to capture student work and thinking. Anyone ever done this one before? This one's a cool one. It's a neat one to do. There's actually, if you go, yep.
How did you get the video to like sit inside of a graph and then like move as you're doing the?
I didn't. I didn't. This is so. If you go to again, we can end it with an activity builder kind of discussion. But if you go to teacher.desmos.com, there are a lot of pre-made activities. This is one of them. And this is one of, I think, 6 different stories within that set, and I just pulled this one. Designing activity builders is not easy. You can get video in there, you can get this, but doing some of the advanced things like you saw where they had the line moving with it, that's kind of higher level stuff that is above my pay grade. I rely on smarter people than me to make cool activities. So, this was in teacher.desmos.com. It's called, I think, just Graphing Stories? Yeah, I think it's called that, Graphing Stories. Right. Okay. So I am going to end with this, and I'll take any questions you have. So if I go back to my slides and things, 4 activities in 60 minutes. I think we got it. We're good. So I will leave you with stuff you can do. First of all, learn.desmos.com. This is where you can go. It's your one-stop shopping for all things Desmos. They do have it down. I'm moving out of the way. They do have it down to the granular level if you want to learn about any of these little things. PE packs are cool too. If you're planning to just do professional development with your own teachers, you can get all the slides. So things like charts that I did today, they're in there. So all the slides we use for training sessions are in there, and you can grab them and use them however you like. It's all free, all open, free to use. Okay. And I will also point out, very exciting week in the Desmos world. It had been behind the scenes for about a year and a half. I started to get these little emails about, can you look at this? Can you tell us what you think about this? Last week, statistics functions came out in Desmos. So there's some examples. You can do box plots, histograms, all kinds of stuff. I'm an AP stat teacher. You can do normal distributions and binomial distributions and stuff like that. If you're the least bit interested in that, I put an introductory video on my YouTube channel. That's there. I have a couple other things there, like how to do linear regressions and whatnot. So feel free to contact me, harass me with your questions and whatnot. And just a couple cheap plugs. Again, we have Desmos coming to Westchester in June. I'm also the program chair for the PCTM conference. The Pennsylvania State Conference will be in Harrisburg this coming August. Dan Meyer will be there, Robert Berry will be there, and we have a Desmos pre-conference the day before. There'll be a lot of stuff there as well. Look for that. In fact, the registration is now open for the PCTM conference. If you've ever been to the PCTM conference, this one will be 3 times as big. It'll be the biggest one they ever did. We're expecting maybe 700 people this time around. So we'll see how it goes. 12:30. Thanks for your time, guys. You take care. All right. Yeah.
Sorry, that's not Snapchat feature.
Snapshot's cool.
That
Yeah.
wasn't. When did that end?
Snapshot started May, June, somewhere around there. It's neat, but there is a learning curve to. You have to kind of know. Okay, I have 30 seconds to go, and know what you're looking for. I'm looking for one that's plausibly right, one that's wrong and interesting, one that's like a step away. That's kind of my mindset when I do them. I'm always looking for four.
I'm doing a thing on 3-act lessons tomorrow and paired act. It's
Yeah.
you do that. You star, you pick the great
Yeah.
one, the interesting one, and the wrong one.
Yeah.
But it's similar because I'm thinking, man, that's just like the paired act
Yeah.
after. That's pretty cool.
Yeah, it's pretty neat too. But there is a learning curve to kind of figure out how to do
Sure,
that.
sure.
Mark, it's good to see you again, man.
Yeah, always.
Yeah.
Always. I'm hoping to get
So
out.
say thank you.
Thanks for having out, Jeff. I appreciate it. I'll see you in June. That'll be
I'll
great.
be there.
Fantastic.
See you, bye.
Hi, Doug. Go ahead. Good to see you.
I follow you on Twitter.
Yeah, awesome. That was a mistake.
Oh, no, so no. I recommend for Desmos. I have a draft version of the fellowship application. I use Desmos. I've never created a true mind-blowing.
Don't worry about it.
Okay, so it's not for like the top tier. Because I'm okay with rejection, but I'd rather go to the Philadelphia one. My wife's we have a 7-month-old at home, so I either have San Francisco, which is awesome, on my daughter's birthday weekend, or I can do Philly, but I can't do both.
So the difference is that Philly will be just training for things. We will show you how to do stuff. We'll differentiate. The one in San Francisco is you become a fellow and you are kind of behind the scenes. You get access to new things, to ask for your advice on things, and potentially you become a trainer as well.
Okay.
I mean, the training is awesome. You get to meet a lot of people. But if you're just wanting to, if your goal is, I just want to learn more about Desmos, just come to the Philly one.
You think
But-
that's more than adequate?
Yeah, more than adequate. Yeah, we'll have 2 days, and we'll spend. The normal flow is we spend the first half day on calculator moves. The first afternoon is activity builder. The second day is how do we build activities. We'll do it together, and then we differentiate by if people want computation layer, or we're going to have to add statistics to it.
Which is awesome.
Yeah, which is going to be cool. So yeah, we're already thinking that out. So if you just want to learn how to do it for your class and take care, just come to the Philly one.
Okay.
It'll be cool.
That's my only concern. Is like I don't want to. Again, if I say yes or no, obviously yes, it'd be incredible. San Fran's awesome,
Yeah.
but I don't know what the level would be for out there. My
It's
goal,
all- it's all
my
over.
goal is to learn Desmos and
Right.
really apply to all of my classes, not just Calc and Greek out.
Part of it is too, and a lot of their message with those applications is not only how are you using it, how are you facilitating and helping other people with it, and that's kind of the
That's it.
expectation of it. If you're there, great. If you're not there, that's fine too.
I am kind of like our district.
If you're the
Desmos
guru from
nerd.
around,
And GeoGebra.
GeoGebra's pretty cool.
I'm going to MoMath in New York in March, on March 30th, but GeoGebra day there, and I'm going to learn GeoGebra because that's been.
I will tell you
that's
that
night
if
and
you
day.
come to PCTM, I know as program chair that there are at least 2 or 3 sessions on GeoGebra. Tim Brzezinski, he will be there. Steve Phelps will be there. Steve Phelps is GeoGebra, and he's also Desmos. He's Desmos fellow as well. He does both.
Okay.
He's going to do sessions on both. So there's going to be people there for GeoGebra.
August is already booked.
Oh,
Very
yeah,
sad, so
too
I
bad.
agree. But listen,
Yeah.
outstanding presentation. Thank you, sir.
Yeah, appreciate that. Take care. Hi, Melissa. How are you? Good to see you. How are things?
I just wanted to ask, do you come to schools to do training?
I do.
You do?
Usually
So
you have to go through Desmos and you go through hoops and whatnot, but honestly, if you had a need for a one day, just contact me directly.
Okay.
They don't care. I'll do it cheaper for you.
I was
anyway.
going to say, we're middle school Algebra 1, but
Right.
I would love to introduce a lot of our lessons using Desmos,
Right.
like the linear stuff.
Right.
Get them, bought in.
And that's where we could.
And I feel like you're a really dynamic speaker,
Yeah,
so
that's,
you
thank
could do it.
That's where we, and that's also where we have to talk and say, okay, what are your needs? If it's calculator, great. But if it's we want to talk about lessons and how do we facilitate a lesson, it really becomes a lot of role play.
Yeah.
It becomes okay. Someone act, find a lesson. You act as a teacher. You act as a student, and go through that
Bring it
interface
together.
because you have to feel what that looks like. So if you have idea, what are you thinking as time frame?
Maybe like a day in the summer.
Maybe in the summertime. Just let me know.
Okay.
Email me. And
I
let
would
me
say
know.
I can start with you, and then
Yeah,
if
that's
you
fine.
have to kick me
Yeah.
to Desmos, you can. But
Yeah, no, I probably won't. I'll tell you, if you go through Desmos, I actually don't know what they charge for a day, but they pay me $1,000. However, if I was doing it just for someone around here, I would charge less, and you wouldn't have to go through the Midland.
Okay.
So we can figure out.
All right, I will probably email you, so look out.
Sounds good, Melissa. You take care.
Thank you.